Hello everyone. Well, I don't really know everyone, but okay. Let's start this thing. Let's see how this works. I think it's the first time I'm streaming for a long time. And yeah, let's see. Let's work together on this app. No, this is not the right one. Let's start as well. Let's open the one I'm building right now. So what is this? Let's go first in the last changes. Let's go to this revision. And let's build the app. Well, there were a lot of changes in between. So basically what I'm trying to do, we have here a Jetpack Compose Desktop app, which is, Jetpack Compose, but on the desktop, not on Android, as one would expect. And I'm trying to build kind of a Flipper app, FB Flipper, if you know, this app where you can debug your mobile device, Android or iOS, for now only Android, on the desktop and communicate with the app to make whatever you want with it. So I'm going to try to run it already. Let's see. I think I have to Jetpack Compose Desktop here on the right. Let's do run. You shouldn't compile the app correctly. Let's turn on the server because there's a server here. npm start. Here we go. We have the desktop app running. Yeah, so well, I started developing it a few weeks ago, and a few months ago actually. Still, being a full-time developer plus parent doesn't give much time for side projects. But anyway, what I'm trying to do now on the device is to open the app. It doesn't do much. Let me first check that I have there's a copy here, screen copy, sorry. Do I have it? Yeah. But my device is not connected, so wait a second. Let's connect the device. Up. Okay. And now we should be able to run screen copy. Okay, here we go. Nice and smooth. So let's have the server. You see that there's already some communication since the device connected. And if we look at the desktop app, nothing showed up. Great. Because the app is closed. So let's open. And here we go. We have already a panel on the left called Pixel 6, Google Pixel 6, because it's, my device. There's a little SDK that communicates with this server, as you can see behind. Communicates its information, who basically is this device. And the idea is to be able to look inside here, what are the values, some app state if the app is in foreground, if I go on background. So if we go in background, so here we're just in the background, we can see the Jetpack now we have in background. And if I actually go and kill the app, we're disconnected. Great. Yeah, I should prepare my device a little bit better for next stream. So yeah. Besides that, what do we have here? So here all the fields are clickable to be able to copy them. And if I open the SDK again, I can see we have also a favorite button here that lets you put the device in favorites, and if you actually kill the app in that time, so you get that the app is disconnected, but you don't lose your favorite devices list. You can still close it and open it. Nothing will show up here afterwards. because all the device is disconnected. But we already have device information and logs that are implemented. The logs are catching only one thing now. There's only one button in this test app called Intro. Here it's a button. So if I click on the logs, I should have been able to see data. So we might have a bug here. We'll check that later. On the device information, we already have it. And network, there's nothing done yet. So the interesting thing is to see why. Let's maybe debug this. Let's see why we don't manage to have it click. You see, I can click on the device, but I don't have anything happening on the desktop app, the Jetpack Compose Desktop. And it's mainly a problem of communication here. So let's see if our server, actually, I have a feeling that no, the device is there. If we click here, we do have connections. So something is not updated. Because when we click here, we have, this is a log sent by the little SDK on the device to this npm, the Socket.io server. And we should have been able to see the connection. Maybe if we don't have it in favorites, do we have a better connection? No. Let's try to put this in this connection. Here, another bug. We don't have a device and we have this panel of logs still showing. That doesn't make sense. It should disappear. So let's see what is going on. So how this app is built. For now, it's that was my first assumption, is that I'm going to be able to work on Gradle and basically split up this project that is one Gradle project. You see there's only one settings of Gradle.kts, and split it up into different, here we have old folders here because of the change, but here we have features, and I'd like every one of those features, even the main things, to be part of their own Gradle sub-projects, maybe even their projects. But here I'm quite surprised that the logs don't show up. So I'd like to see what's the problem. So how does it work? We have a main, and main is the, well, like every JVM application, the main is the function that runs first, launches a single window application that is part of Compose UI, and shows up this nice app that we have here. And we have Dagger components to manage the screens as components, which is basically a class of ours. It's not special to Dagger. Material team, and then we start the component here, a main component that looks like this, which is simply a class to be able to inject and call some init functions on those on repositories and render. So I set up this app to work more or less like what is it called? Like an MVVM architecture, where we have in the common part here, we have a VM and we have a repository, which is just an interface to have a base, like not a base, but some kind of central unit to say what it is. It's really a few. A new state as well, just an interface to define that the new state exists. A use case and a view model, which is just an abstraction on containing a new state and a view model scope to look like the Android one, the Android view model, but it's not. It's just a class. You see, there's no hierarchy here. We don't have Android code here, and this is one of the most surprising things usually on Jetpack Compose on the desktop. Is that you suddenly realize you have a missing piece of code that is coming actually from Android. What else do we have here? Some the main Dagger components for the application with all the models. Those should be at least each one of them their own sub-project, meaning a module in the main project here, which is not the case today. Today it's all together, and we'll work on that at some future stream for what I think. And so from this, let's go to the main screen and try to understand why the log is not showing. Let's see the issue again. So here, I'm clicking on the button and we don't see the logs showing up in here. Does it show up on the top, maybe? By mistake. No new timing. Here on the button. So no. Let's restart the SDK completely. The app, maybe there's a miscommunication. No, I don't see new messages here coming up. Okay, interesting. It's a good use case for us to start to know this intra app and look around what's going on. So we have the main screen, which is the whole this is the main screen with both devices and what I call panels or tools. And on that part, we have a vertical splittable. This is this panel. This is the vertical splittable, so we can resize it if we want to have some more space for the right panel. And what I can say is that, let's go forward. So in this vertical splittable, we have the device list component. Please remember, so we don't recreate it from an assisted factory from Dagger, which is this. It returns a devices list component, which receives an on-clicker. We don't want to recreate a new one on every recomposition, so we remember it at once, and then we just render it. So every time this is recomposed, we're gonna get the same devices component. We don't need to recreate it for the on-click listener here, and we just render the same. So this is how all the components, the Dagger components, are working here. Sorry, not the Dagger components. Maybe I should call it differently because it could mismatch with could confuse with the Dagger component. It's more like a composable component because it has a function composable from render here. And so we have the list of tools here that is rendered. Let's see what we have here. And the tool component gets its view model, the view model to be able to get the information of the device, the logs, to be able to pass them to the right tool screen. So what's going on is that this is the device screen, device list screen, and this is the whole left panel, right panel is the tool screen, which receives everything needed to show the current thing. So the factories or the module themselves needed for generating, creating their own view models, or this comes from Dagger, and we have to do it manually because we just have a JVM app. We don't have activities here that we can just add annotation inject on them. So what do we have in the tool screen? Device info view model to be able to show the device info. This comes from a view model, which is a view state, of course. That is device info UI state. Next, we get the information of the device. We have a toolbar and we have different information. So here we have what if the tool's UI state is logged, meaning the user of the app pressed on logs here. So we're getting to the place where this log should show up, but we don't see live anything, so we'll see why in a bit. We have, again, we remember the, depending on the identifier, the device itself, the log, so we can replace it if the identifier changes for the same window and different devices basically. And we log we show the logs the logs component shows up and shows a logs list screen. Okay, so here we get to the main interesting point. So this is a logs list tree. It shows a list of logs, makes sense. And you get a view model and its identifier. So the parameters needed to show this the logs. So once we enter, depending on the view model, we use a side effect called launch effect to launch it once on the recomposition and on the first composition, sorry. And then we call load logs on by identify, which triggers use case. As we said, we're using a VM here with the identifier to collect through flow the list of logs that is currently shown, and we throw them back as a logs UI state. So something here doesn't get triggered. Let's see if we can just debug this. Why can't we? That's interesting. Let's see if we can debug here and understand why we cannot. Let's just stop it for now. Why can't we debug it? What's going on here? I love this when we have live issues on what's going on. Since then when I do the run, okay. I don't know what happened here. The configuration got lost. So if let's debug it instead. Here we have the app. We're clicking. Oh, we do have an error here. Interesting. Parameter specified as null, as not null is null. And this happens every time? No. So is it related? I'm not totally sure. It could break the repository to collect things. So let's see what's going on here. The identifier is null. How's that possible? What happens is that the server, let's see what the server sends back. So if we debug it, we can see the list of let's look at it. So we have logs here because we already have data coming from the database. What's interesting is what the server sends back. So it gets a message, publish type, logs timestamp. The server doesn't send an identifier somehow, as we can see here, which should be sent, so the device can allocate the log to the right device, to the right saved device on the desktop app. And we do have it, because while the server knows who sends on its own socket the data, so it should be sent. It's weird that the server doesn't do it. So let's add this. Let's open Visual Studio Code. Up. And here, how the server looks. So it's where are the dependencies? So Socket.io server, a script, JavaScript server, more correctly, and with some express to be able to get a health ping that we'll use later, way later. And for some reason, let's go to the part where the device should be, the log should be sent. So here's the data that is sent, and we made that log. So if we look at the console logs identifier data, and we see that the client to this identifier emits only the data received by the client. So there's a missing identifier here to be able to save it correctly on the client. So it makes sense that this doesn't work. We found the issue. So how do we fix this? First, I want to see what is inside the data, and that we saw in the logs here. Logs, ID, and this is what we get. Message, and the type that logs. This is the way of the SDK to the, not SDK, the client, the Android app, the Android SDK inside an app to say what they're sending, when, and the body of the message. And if it's the only thing that is sent to the client, it's missing the logs identifier, because you could be potentially be able to listen to logs of multiple devices, and you want the server to tell you which device it comes from. So we have message, publish type, timestamp. So what we can do here is to send a new object, because it looks like what we're expecting here in the repository of the logs. Let's look at logs repository. We feed a database with a log line entry event, which is a line, and it's different. And so there's already, so we're not aligned here at all between the server and the client. So I think the client could send all the information directly to the server, and the server just forward it to the right client. So we need to change the format on the client to line, identifier, and device timestamp. It's not what the device was being sent. So for that, we need to open Android Studio. Let's open Android Studio. And we will, so here is what we have. We already have a client that does the communication with the server and has an API ready to be used by devices to send logs. So let's see what is sent here. When we're talking about, we have a client publishing a log line here. What do we have in as log line? The Device timestamps and line. We should be okay. We should be fine. We should the log name is sent as this event, and we just define. I guess I don't have the right version here. Let's update the version on the device. In the background. Okay, so we have device here to show some stuff. Okay, maybe I'll move this. So we always have the device able to see it. Would be nice. I have to show it every time. Here we go. Okay. So now we send this. Let's see what are we're in Android Studio. Look at the logcat. So that happens because the client listens to the server to know how much devices are actually listening, how much desktop apps are listening to the events of this specific client. So if we run it and we click on logs, the client when pushed, here we go. So the whole thing was that the version on the SDK version on the device wasn't updated. So now when we click, we do have live event. Okay, so that was really not necessary. All this mess, all this debugging, but fine. It was a good opportunity to start explaining how this app works here. Okay, so what about Gradle? So what about it? The idea here is that we have one setting.gradle.kts, and we have no modules. We have a source. Actually, all the ones you see here are, I should clean up the mess. Let's clean up the mess. And go to the desktop and do a git clean FD, I think. Okay. Did you remove everything? No. This is not relevant. This is not relevant for now. And this is not relevant for now. Okay. So we have one source code. It's basically one only project with one build.gradle.kts. Not that interesting here. So what can we do with this? We can, let me look for first we can create modules. That will be the first thing we should do, in my opinion. And we should separate the code into different. Let's first stabilize what we have here. We'll have a look. While we're on the branch. Let's revert this commit. Let's first go check out the name. Then we started some version of project here, but I'm not happy about it. Why? Because it makes a project for each one of them, which is a little bit too much to my taste at this stage of this project. It's a nice improvement when you have a lot of code and many models. But here, I think the number of models will be limited, and it might be better to just have it as one project, one Gradle project with many Gradle submodels, so sub-projects basically. So by Gradle project, I mean a folder with the settings.gradle.kts, KTS or Groovy, doesn't matter. The difference is that you can have the folder where we have a settings.gradle.kts is considered a Gradle project, and every submodel inside, every model inside a set, a Gradle project is called a Gradle subproject. And here it should be enough. So we can start by creating a model. And we'll call it, so we have the main app. The big piece here, the first big piece is the communication with the server, I would say. And I'd like this model to be separated into two, the interfaces and the implementation. The app itself will have the implementation, and every other model that needs the client to listen to something, like every tools like logs, network, or whatever, will take the interfaces. So we'll be able to see the interfaces, but then the implementation, which is the right thing to do, because any other model don't really need the implementation, just the interface. That's the whole point of dependency injection. So let's call it intra-client API, which will contain models and interfaces of the client. Not correct. Intra is the name of the project, so I don't like to Smurf name everything. Smurf naming convention, meaning you start every model, every class with the name of your app or your company. So everything ends up called the same, which has no useful purpose. So let's call it socket client API, because we're in a socket architecture. This is an important part of the communication here, that it's on a socket. Doesn't matter that it's socket IO or whatever. We don't need to be so specific to the implementation of socket here, but we do want to know that it's a socket client API to know that some things are happening live. Anyway, let's create a model that is a Java with Kotlin, and it's a Gradle, of course. Yeah, that's the case, right? We can add some sample code. It doesn't really matter. We'll delete it later. Now let's remove it. We don't need it. So now we started with the socket API model. Let's delete all the things that are not necessary again, because we don't need more than this. This will manage another time. Oh, I removed also the model. Okay. What I do want to do is to let's do some order here. I'm making a mess. So what are we? What branch are we? We're on branch main, and we deleted manually. So let's first do to make it clear. Let's get hard. Let's reset for the project, and then we can simply delete this commit basically and go back to this one. So we could reset hard to one before. Okay, I'm never sure of the syntax. Let's try it. Where's the little hat? Head tilde, I think 1. No. What is the syntax? Let me Google that quickly. There's one blog post that I always go back to. Okay. Yeah, I don't need the basically, and I didn't say that it's first it's hard, and then head to the one. Okay. And now we basically lost the last. We're in the logs cleanup. Here we go. Now we're back to a normal project without all the changes required that I made previously that weren't really bring any value. So let's create a model. Let's do some refactoring here. What we came to do in the first place. We go to, let's create a model as we did before. We'll call it Socket Client API. We'll have here only the API part of it. Here we go. We have some basic build file. We have Java, but we want Kotlin. So let's bring Kotlin. We'll have to do something about the versioning and the libraries later on with version catalogs. For the meantime, it's okay. Let's have Kotlin here. We don't need a group now. We don't need the repositories. We already have them in the settings here in the plugin management. And this is included already, so that's good. Maybe we do need this. Let's leave it for now. We'll concentrate on that later. Right, we don't need the version because we already have it. The class path because the project is already coming. We'll need it later when we don't have a nap here running and that is not applied. So because this is applied for now, we need it also differently in a different place. So here we go. For now, I didn't have added tests yet. It's actually something I wanna go deep dive into in another session. So let's create just this model and use it for now in the app because, well, till we manage to actually have its implementation in API and have a feature that is a model, that will take us a few more streams, I think. And so we can start by moving code form src here. We have by packages already in the common client, and here is basically everything we want. Not everything. Here everything is together, the implementation and the interface and the implementation, but we do want the interface in this project. Let's call it, we can have a Kotlin folder instead of a Java. We're not, who develops Java anymore? We have only Kotlin. Let's create a package, a proper package. Dev intra desktop. This is the base. Socket client, something like that. I don't like to put dashes here or underscores. Prefer to have a package, although it should be together. Socket client like this? No, not right. Let's say that it's the socket stuff. And here we'll put the socket client interface. We'll rename it later, but if we do that together, Git will not know that the file is the same. So let's just move it and break stuff. So we don't have flow. We don't have this model. The model are very easy to find, are right here and right here. So those ones we can move as well. Yeah, let's break everything. And flow, state flow and shared flow come from the library called coroutines. So we just need to bring the dependencies there. Where are we? Coroutine extensions. Let's put it back here. Sync. And we should be good to get it. Here we go. Let's clean up the import. Doesn't look cute for now, but it's fine. We have the definition of a device for the client, the inside implementation, and an event also. The identifier when it's sent, and a log line is the same with the line itself of the log. So here we go. We have a socket client API. The problem is that you can see here we don't have it anymore. Nothing works. So let's just import this module inside the main project, which is added here, but not inside the build Gradle. So this is the main app for now. Doesn't know where this thing is. So let's just bring it up with implementation of project called how do we call it? Socket Client API. Here it doesn't find it yet because we moved the package, so we need to re-import it. All those models changed packages, so let's re-import them too. And what's going on here? The same for the model here. This is a feature that actually will, this is the implementation, so that should go right inside its own model. We'll do that after if we have time. I don't know what time, how long are we? I'm recording here. 42 minutes already, wow. Time flies when you're just talking to yourself. So let's fix the import. Let's build the app. See if we can build the app already. Probably some other imports are broken somewhere. Here we go. So we have some more imports to fix. And the imports also are not correct. I'm going to put here the shortcut plugin later. So you can see the shortcuts I'm using while I'm writing this code. It's built. Our component doesn't know the import, is missing stuff too. So let's see what is missing. No, it's the logs repository that has the wrong import. Okay, optimize import. Let's run it. Basically, we're fixing all the imports from this because we moved the package, so we need to fix all the imports. Let's continue. Some helper functions here that requires also the same model. Go next. At some point, we'll be able to build it. Here we go. Okay, we moved everything into a model and everything seems to work. Clicking the button now and it works, so we're good. So we have our first model of the API. Now what we need to do is to have a second model for the implementation. And when we'll have our first feature, we'll move code into a model or a feature model. So this is basically like an infrastructure / subsystem / service model. We could put them into one folder also at some point. In their own project, I prefer to wait that we have everything in features in their own models, and then we can more easily move them into their own project. Doing it all together was way too heavy, and that's why I haven't spoken about what I did the previous commit, and we just reverted it. So yeah, let's continue. Let's do this one. A new model, socket client impl. Not sure that I like that name. For implementation. I think it's clear enough. And we don't need more than that for now. So we'll have API and implementation. Let's take some the API Redux Gradle because we mainly need. We're not sure that we need a dependency of the coroutines. Let's see. I guess so. No, we need it. Of course, we need it. Coroutines is the backbone of asynchronous running code, so we'll need it. And so let's apply this. Let's copy the one to the other for now. Here we go. Yeah, so we have now a new model. Let's also have a Kotlin folder. But let's sync it first so we can actually have it recognized by the project. And we'll be able to create a folder Kotlin, source folder Kotlin, delete the Java one. And we had here, oh, we didn't delete the previous one too. We have dev intra, socket. Oh, I think here we should do API. Or we can just, for now, create a package, the new model, dev intra, desktop, socket, implementation. To be really precise, we implemented this interface. Here we'll add API at some point. To have a model called API, so the package is also API. So we already know also by package where the code lives. And dev intro desktop socket implementation. So here we can move from SRC the right implementation. It is in common. The client will have this and the Dagger definition. So we need to bring the Dagger definition imports to our implementation model because this will generate also the model itself for Dagger. Capt, yeah, we need the plugin of Capt. This one. Also, we remove the version here. I'm gonna sync, and Capt should be fine. Yes, we're good. And now we can move those two files. Here, of course, we're gonna have import issues, which is fine. Here, this model also is the one implementing Socket.io, so that's a really good thing. We're gonna start to remove implementations on the main app that we don't really need anywhere else. So, for instance, Socket.io is not used by anyone else than this client. So why do we have it everywhere? It's kind of a mistake. So let's have it in here in the implementation model of the Socket client. And we should be much better suited. Here we don't have all the interfaces because we don't have the dependency to its parent project. Parent project, parent API more correctly, or API, whatever. Implementation project, socket client API, and everything should be imported correctly here. What's missing? Some extension functions. Where are those? In the utils package. This one we can move to implementation, main. Here we go. So they will be in the same spot as before. Let's try one that should have a utils model somewhere. And we need also JSON, the dependency of JSON. I don't know how you pronounce this. Leave it here for now. We're syncing. So the model for Dagger, everything is imported. The client also is working well. And for now, what we can do also is to bring the API, the parent project, not by implementation, by API, which means every child that depends on this project will also get the interfaces, which is good for now for the migration till we finish to create models, so that the app itself will get interfaces, which features like logs, like if we looked at the logs repository, are still using. So they need the interfaces, not only the implementation. So we can bring it by transitive dependency in Gradle. So that's what we're going to do. We're going to not depend on the socket client API anymore, but the implementation, which will bring the API as well. So if we sync this, we should be good. And let's run the app. And we have import issues. As expected, nothing works on the first time ever. We can import the intro module that brings we'll rename that the socket client model should be named. We'll rename all those things at some point. And so we can run this now. And we're good. So what did we do today besides just messing up the project? We moved code from a main for one module, let's say. It was one Gradle project with itself being a Gradle subproject as one code base to start separating the code as this app grows and everything is together. It's basically a really it's a bad pattern. So we started to separate the implementation and the API project into their own project, their own models, to their Gradle sub-projects to be exact. And we use them in the main app. It's a little weird now at this stage because we still have a lot of code that is common here and we don't have everything into model. We'll have a model app, which will be the part here of the main. We'll have feature models that will have their own MVVM, their own domain layer, their own layers basically, UI, domain, and business logic, let's say, layers that are all here together. So we'll have them separated in a clean way in different models. But that's for another time. So I hope this was somewhat interesting for you, and I'll continue, and next time we will continue to do models, as now we're in a clean state where everything works with just one separate. We'll continue the Gradle work separation in the next stream. Yeah, that's it. So bye-bye.